Hello, welcome to Rheology e-learning. Today our topic is influence of solids content on the high shear viscosity. Solids content, we know that coating color solids content influences greatly the rheology of coating color and the runnability of the coater. It's typically 60 to 70% solids content of coating color that are runnable in high-speed coaters. Usually the high solids content is an advantage for decreasing drying cost and reducing binder amount. So it's favorable to have as high solids content as possible. However, if the solids content is too high, there is a risk that the runnability issues may occur. So it increases the risk of runnability issues. So you can't run as high solids content as possible. So it's important to investigate the influence of typical coating color solids content on high shear viscosity, because we know also that high shear viscosity has a very high correlation to runnability. So this investigation helps us to understand how solids content is influencing the runnability of the machine. When measuring viscosity, we have to keep in mind that there are two types of viscosities. First, the structural viscosity, which is a low shear viscosity, where we are creating structures via chemical interaction, and that's why we can influence that part by having thickeners or different rheological modifiers. This can be measured by Brookfield, for example. On the other hand, we have a non-structural part of the viscosity where the shear rate is so high that all the structures are broken, and you are measuring a kind of packing effect of the particles, and that is causing then the viscosity. And this can be measured by a capillary viscometer. And in this study, we are focusing on non-structural part of the viscosity, and we are measuring high shear viscosity curves. This is our experiment. We have a standard GCC for both recipes. We have a latex as a binder and a rheological modifier. And then we have a solids content of 65% for recipe 1 and 70% for recipe 2. So these are the variations that we have between these two coating colors. We have adjusted the Brookfield viscosity, so the low shear viscosity to 1200 millipascal for both recipes, and therefore we have a slightly different amount of rheological modifier in the formulations. The measurements were done with the ACA AX100 capillary viscometer, and as said before, we measured the high shear viscosity, non-structural viscosity. Here we can see the results. So if we look at the curve first, we have a little bit unstable curve for 70% and higher level of viscosity compared to 65% solids. So it clearly shows that when we are increasing the solids content, we are also increasing the high shear viscosity, and because the curve is not anymore so stable, we are reaching the point where the solids content is at maximum, and therefore we have to be careful at this high solids content when we are running these formulations in the machine. We also indicated the ACA viscosity, which is taken from 500,000 shear rate. So there we see that a 5% increase in solids content is causing viscosity increase from 40 to 70. Conclusions. At 70% solids content, the viscosity curve is becoming unstable compared to 65%, and this indicates that the critical solids content is pretty close. The high shear viscosity level is increased from 40 to 71 millipascal, taken as ACA viscosity at 500,000 shear rate. And the optimal solids content depends finally on the runnability and coating quality. So we see now indications that the rheology is becoming more challenging with the 70% solids content, but we need to correlate this data with the actual runnability and quality of the coating in order to set the really limit of the solids content. So capillary viscometer is an excellent tool to test influence of solids content on rheology and achieve significant cost savings. We can see things that will happen also in the real life in the coater. We can see that the rheology is changing, and therefore we can then correlate these rheological results to actual coater runnability, and of course then this is a very good troubleshooting tool for runnability issues. So if you want to know more about the coating rheology, we offer rheology seminars also. We can do that webinar based, or we can do that face-to-face to your team. So looking forward to hearing from you. Thank you very much for today, and we will continue this e-learning series in the future. Thank you.